Hi, welcome to our booth. I'm Sanchita, a graduate student from Environmental Sustainable Engineering Department of University at Albany, State University of New York. I'm a co-author of this poster titled Elucidating Ambient and Indoor Sources of VOCs in Dhaka, Bangladesh. The primary author is Dr. Mohammad Anwari, and the other co-authors are from SUNY Albany and Kent University. In this video, I will give a brief idea about the main section of this poster. Okay. Before go into details, let's look at some background information. According to 2019 World Air Quality Report, Bangladesh air is the worst in the world. Dhaka is the capital of Bangladesh with a population about more than 20 million. Air pollution kills 195,000 Bangladeshis each year, according to the report of WHO World Health Organization of 2016. Several studies have been done to understand the particulate air pollution and sources. Studies are limited in Dhaka to determine the concentrations and sources of organic air pollutants like VOCs. We did an exploratory study to understand what are the potential sources of VOCs in ambient and indoor environments in Dhaka and if there are any health risks associated with the VOC sources. Kent University and the participants in Bangladesh performed the VOC sampling in urban and industrial areas in Dhaka during 2011 and 2013. You can see here the sampling points and different characteristic sites. Mirpur is an urban site and Tejgaon is industrial site. We know that there are several industries in Tejgaon like garment industry, food processing industry, metalworks, pharmaceuticals, and the cosmetic manufacturing. For the VOC sampling, they pumped air for 30 minutes and collected samples using sorbent tubes and analyzed the VOCs using TDGC-MS. As VOC data are very limited in Dhaka, we just leveraged those data and tried to understand the VOC sources in Dhaka. For data analysis, we applied US EPA PMF 5.0 for the source apportionment study. For screening human health risk assessment, a deterministic risk assessment of the inhalation exposure pathway was performed to identify the VOC species or sources that may pose to the greatest risk. Carcinogenic and non-carcinogenic risk of all risk-posing species were estimated and summed for a particular source. I'm showing here some preliminary results from the study. You can see here we found significantly higher concentration of the VOC in industrial street location and also in home located near the industrial site in Tejgaon. Here, as mentioned before, we applied the PMF model at first to ambient data set and resolved 6 representative sources. And these are traffic, industrial solvent usage, chemical and food industry, timber and furniture, manufacturing, consumer and personal care products, and the mixed industry. Then we apply the model to pool data set, including both ambient and indoor data. Here we can extract 4 additional indoor sources. They are the floor and wall coverings, fragrance consumer products, indoor evaporative emissions, off-gassing of building materials. From this exploratory study using low sample size, we found traffic as a dominant contributor to ambient VOC in Dhaka, followed by the industrial solvent use and the chemical food industries. When we observed the notable contribution of floor and wall coverings to indoor VOCs as well. Unfortunately, this study didn't measure some tracer compounds for fuel evaporation and fuel combustion, so we couldn't identify those sources in Taga. Now, screening human health risk assessment. For screening risk assessment, you can see here the pollutant that's the VOC specific risk. We calculated the lifetime excess cancer risk and assumed that the exposure occurs at the same level, 24 hours per day for 70 years. We found the benzene, ethyl benzene, and naphthalene exceeded the US EPA acceptable cancer risk level, which is 1 in 1 million, but they are less than tolerable risk level. And now, if you look for source-specific risk, we found almost all sources having exceeded the US EPA acceptable risk level. So this exploratory study highlights the importance of the minimizing emissions from traffic and industrial activities to keep their levels to the acceptable level. So the key message. Traffic was identified as the major VOC contributor, followed by industrial solvent use and chemical food industries. Indoor VOC sources include floor and wall coverings, fragrance consumer products, indoor evaporative emissions, and off-gassing of the building materials. Carcinogenic risks of most of the sources were above the US EPA acceptable level, but below the tolerable risk. And finally, future work is needed using larger sample size to better understand the local and distant ambient sources as well as indoor determinants of the VOCs in the capital of Bangladesh. I'd like to acknowledge the Kent University for giving us the provision to use the VOC data and our university at Albany to perform this study. Thank you very much for your attention.